Hi, welcome to the video. Okay, here's the problem we're looking at. We're talking about a random number generator again, but notice it's a little different now. This time, instead of generating one random number, we're going to generate two random numbers, and then we're going to add them together and call that new number y, so the sum of the two random numbers. And it's interesting to take a look at the density curve we get for y. Notice that now all sums aren't equally likely. The sum that we get could be anywhere between 0 and 2. So take a minute and think about, well, what would the two numbers have had to been for their sum to be 0? Well, that means that both of our numbers would have had to be 0, which is kind of unlikely, so that has a very low height of the density function. Similarly, for the sum of the two random numbers to be 2, both numbers would have had to have been 1, and that's also less likely. On the other hand, for the sum of the numbers to be 1, or close to 1, we're seeing a very high, taller height on the density function, because there's many ways that that could happen. The sum of the numbers will be close to 1 if either of the numbers, or if both of the numbers are close to a half, or if one number is much bigger than a half and the other is much less than a half, we still get a sum close to 1. So we can see with this density function that if we take two random numbers between 0 and 1 and add them together, it's going to be most likely to get a sum close to 1, and less likely to get a sum close to 0 or a sum close to 2. So there's some intuition about the problem. Now let's take a look at the specific question they're asking and how we might start to solve this. So they're asking, what is the probability, let's draw, what is the probability, oh, there we go, sorry about that, what is the probability that y is less than 0.35? So if we think about this number 0.35, excuse me, that's our value of interest. Let's think about where that falls on our density curve. It's about a third of the way between 0 and 1, so somewhere we could estimate about here. When we have a density curve, we can always calculate a probability by finding the corresponding area under the density curve. So we're going to draw a line up from 0.35 and say now we're interested in the probability that y is less than 0.35, so we're going to shade in everything to the left, this little triangle here. Take a minute and notice how this type of calculation we're doing is similar to what we did with normal density curves. If the shape of this density curve hadn't been a triangle but had been a bell-shaped normal curve, we could use the normal CDF command to tell us this area in red. Unfortunately for us, or maybe not unfortunate, but as a twist on things, we don't have a normal density curve here. And so we need to find this area, so we're going to have to remember some geometry. If we look at that area there, notice it's a triangle. So that's where this little hint is going to be very helpful. Remember back to your geometry, for a triangle, the area of a triangle can be found as 1/2 times the base times the height. So that's the formula that's going to get us the answer here. So if we think about that triangle we've got, let's write that out so we can fill in the values. The area is going to be 1/2 times the base times the height. All right. So if I look over at my triangle, the base goes from 0 to 0.35. So the length of that base is 0.35. So we know this value. Now we need to find the height of this triangle. How far is it from this point on the horizontal axis up to the triangle? That's a little tricky. If you haven't taken geometry in a while, you may not remember this rule, but we've got another hint in here that's going to help us out. They say the height of the triangle you draw, so we just drew that red triangle, will be equal to its base. This is because of a law of similar triangles. You don't have to worry too much about the geometrical fact that makes it true. It's going to be enough to use that hint and say, okay, this side was 0.35 because it's a similar triangle here which had 1 and 1. This will be 0.35 and 0.35. So the height here is also going to be 0.35. As you do this problem, focus on the statistical concepts that are happening, right? We had to draw an area, shade it in, figure out what its side was. That's the process that's always going to be true. These little geometric tricks will always give you hints about those if you need them. So let's calculate it out. Area equals 1/2 times 0.35 times 0.35. So let me get my calculator out. I'll go ahead and put that in. I'm going to put in the 1/2 is 0.5 times 0.35 times 0.35. And the number I get as a decimal, I'm getting is the area, area area equals 0.06125. So that's the decimal calculation of the area. I'm noticing in the original problem they asked for the area as a percentage, so I'm going to multiply that by 100, and it turns into 6.125%. So I would write in here for my answer 6.125. So if we go back to the original story, what is this probability telling us? It's saying if I randomly pick, or if I have a random number generator, pick two numbers between 0 and 1, and I add them together, what's the probability that their sum is less than 0.35? Well, the probability of that is about 6.125%. So it's not going to happen very often that the sum of those two numbers would be less than 0.35. And this matches my intuition because I can think, well, in order for the sum to be less than 0.35, both of the numbers that the random number generator picked would have had to be very small. Okay, I hope that was helpful.